In this lesson, we're going to review solving one-step inequalities, something that we've done before, but I just wanted to go through real quick, solving the different type of inequalities that we've seen. So in this first one, we have a is minus 12 is greater than or equal to 47. Now remember, this symbol acts a lot like the equal sign in an equation, which divides our inequality, in this case, into two parts. I know a lot of you like to draw that line down here to help show you your left side and your right side. I'll do that on this first one, and the rest of them I'm not going to, but if you want to, by all means, go ahead and do that. So if I'm going to solve this inequality, like before I'd solve it like an equation, I'm going to add the 12 to both sides to get rid of that minus 12. And when I do that, now my left side is going to say A, and my right side is going to say 59. My inequality symbol, remember, it's not going to change if I add the same thing to both sides. So when this inequality is all done now, I've solved it. It's telling me that A is greater than or equal to 57, which really means that A could be any number that's bigger than 57 or equal to. So the number 60, that would be a solution to the original green inequality. Now in this one, I'm going to do the same thing, solve it, but in this case, when I'm all said and done, I'm going to put my solution into set builder notation. So this time I'm going to subtract 9 from both sides to get the B all by itself. Now in this case, B is going to be less than negative 16. Remember, when we subtract the same number from both sides, we don't change the inequality symbol. It stays as is. Now set builder notation, remember, we use these little squiggly parentheses to tell the reader what our variable is, and then we use this little line that means such that, and then B is less than negative 16. Close it off with your little squiggly parenthesis, and then this would be our final answer when it asks for it in set builder notation. This time, I want us to graph the solutions to our inequality. So I have 14 is greater than negative 2c. So before I can graph it, I need to figure out what my solutions are. So to do that, I'm going to divide both sides by negative 2 to get that c all by itself. 14 divided by negative 2 is negative 7. Now here's the part that we have to remember back to. If we multiply or divide our inequality on both sides by a negative number, we have to flip the sign. So then my sign will flip to be like that. Now I like to read this as I refer to as backwards, so I'm going to start here with the c. c is greater than negative 7. So when I come down to my number line, I'm going to focus on the number negative 7, negative 6 and negative 5 and so on are going to go to the right, negative 8, negative 9, negative 10, so on to the left. Now if I have to graph c is greater than negative 7, since I'm not including the number negative 7, we have that open dot, and then I want greater than, that's all of these numbers to the right. So any number, negative 6, negative 5, so on, is going to be a solution to that original inequality, the blue one up at the top. My next one, another one where there's multiplication involved. This time, again, we're going to go back to set builder notation, but I'm going to just need to divide by 7 on both sides to get the d all by itself. D, and then on this side, I'm going to leave it as 22 sevenths. It doesn't divide evenly to give us an integer, so I'm just going to leave it as 22 sevenths. Now, remember, we're dividing again, but since we divided by a positive, that sign doesn't change. It stays as is. Now, to put it in set builder notation, just like we did before, our little squiggly parenthesis, the variable, such that, and now here are all of our solutions. Anything that's less than or equal to 22 sevenths. And there, again, is our final answer in set builder notation. Now we have fraction. Remember that fractions just mean to divide, so when I look at it, it's really saying e divided by 5 on the right side. So for me to get rid of that divide by 5, I'm going to multiply both sides by 5. My 5's divide out, become 1s. I'm left with the e. Here's the 45. Again, we're multiplying by a positive, so our sign inequality symbol stays as is. Now, if I'm going to have to graph that, well, I'm just going to come down here and focus on the number 45. Again, I'm going to read backwards. E is less than, or excuse me, let me start that over. E is greater than or equal to 45. Now, since it's equal to this time, remember we have to fill it in because 45 is a solution. All those numbers greater than are over here, and I've graphed my set of solutions. I'm going to get rid of that. There we go. Here again, we have another fraction, so I'm going to solve that. I got to get that f all by itself. I'm going to multiply both sides by -7, because the negative times the negative on the left side is going to give us a positive. The 7s will divide out, and then all we're left with is f. Right side is -21. Now here's the part, remember, be careful. Just multiplied by a negative, so we have to flip the sign. So now it's going to be greater than or equal to. We've solved it, so it tells us that that blue inequality has solutions of all numbers greater than or equal to -21. -20 would be a solution. The number 55 would be a solution, and many, many more. Now I have a word problem here. I like these because these help us to think. They make us work harder at our math. So I threw a couple of these on here at the end. And this one says 7 is at least 5/3 of a number. What numbers are solutions? So I've read through it. Now I want to get into it and break it down into little pieces to hopefully make it a little easier to solve. But I like to start at the end. It says what numbers are solutions? That's telling me that I need a variable because I don't know what those numbers are right now. I will in the end, but right now I don't know what they are. So I'm going to say that n is going to be my variable, and it's going to represent a number, or in this case, probably many numbers. And then I'm going to go back to the beginning. I'm going to just start pulling pieces out that are important. I look up here and I see 7. Well, that's going to be important. I'm going to need that in my inequality or equation, whatever one that it comes out to be. I then continue on. It says, is at least. Well, is at least is going to tell us that we're going to have a greater than or equal to symbol. Continue on, and then it says 5/3, a number, so that's important to us. The word of is in here. A lot of times, not always, but a lot of times the word of, remember, means to multiply. And then it says a number. Well, we've already talked about that. That was our variable, so I just put our n in there. And now we have an inequality to solve, similar to the ones that we've solved in the previous slides. We've got to get the n all by itself, so we've got to get rid of that 5/3. So remember, to do that, I'm going to multiply by the reciprocal. The 3's will divide out, become 1's. The 5's will divide out, become 1's. And all we're left with is n on the right side. But if we multiply the right side by 3/5, we better multiply the left side by 3/5. And when we multiply that, remember, we'll end up with 21/5. Now, remember, we multiplied by a positive, so our sign stays as is. And we have n is less than or equal to 21/5 if you read it backwards. Some of us like to have the variable first and our number on the other side. If you do that, you're flipping the inequality around, so then we flip everything. So either one of those would be solutions to that word problem. So we found all the numbers that are solutions to that first little sentence there. And then my last one, it says Mr. Root is offered either 15% or $21 off his total shopping bill. How much would he have to spend to make the 15% option be the best one? So I'm going to go back to this question. How much would he have to spend? That's telling me that there's my variable because I don't know how much I'm going to spend. In this case, I'm going to use B as my variable because that's going to talk about either my total bill or, as it's underlined there, the amount that I need to spend. Now, it's the amount to spend that makes the 15% option the best. Because I'm looking up here, I have this offer. I can either go 15% or 21 off of his total shopping bill. Well, when it says 15% off of his total shopping bill, I'm going to turn that into the 15% into a decimal. 15%, remember, of means to multiply. My shopping bill, well, or my total bill, that's the part that we were just talking about, to be. So if I take 15% times my total, that's going to tell me how much I could get off. Or the other part is it could be $21. Now, we want this part right here, the 15% option, to be the best one. So the way I interpret that is that one should be the most savings. So we want it to be greater than the $21. And when I just said greater, that tells me the symbol to put right there. Now we don't want it to be equals to, because if I had the equals to sign under here, then the 15% option could be equal to it, and that wouldn't be the best one. Then either one would work. So we do not want the equals to. There's our inequality to solve, and now we just have to solve it. So I'm going to divide both sides by 0.15. This comes out to be B. This comes out to be 140. We divide it by a positive, so our sign stays as is. Since we're dealing with money in this case, we want to know how much to spend. Well, it would be $140. So as long as I spend more than $140, the 15% option would be my option of choice. That's going to end it. So we went through a bunch of examples to help remind us how to solve one-step inequalities.